The minimum size for text is advised at 18 points, and occasionally in graphics, 14 points are used, and very rarely in detailed graph you can use 12 points font. When you prepare slides, you can provide a roadmap and use it as a summary of slides before, just like this. Okay, topic 1, topic I to topic N, to highlight the subtopic matters under discussion. Use this, and you provide a audience a roadmap to tell the audience where you are, because your talk maybe last 1 hour, 2 hour long. That means our audience forget what you're talking about, where we are. Just like this. This is a example of my own presentation in University of Wisconsin, because you see this is a kind of roadmap. Where discuss the background and motivation, problem formulation, Lagrangian regulation of framework, and so on. So first item is background and motivation. You highlight as a red as that's where you're talking about. And also the background and motivations and bullet 1 and 2, and then you come to the second content of the problem formulation. Okay, and in problem formulation you talk about the bullet 1, bullet 2, and then see here come to the last item you are presenting, the numerical testing. So using this roadmap, you tell the audience that where we are talking about. This is a good practice. Don't change notation halfway through a talk by copying those for another talk to save effort. Because if you use, say, a circle to represent something, you represent the same thing throughout the talk. Do not change it halfway, because the audience may get confused. If you're using a rectangle, okay, 用一个长方形 representing some process, use it all through your talk. Okay, you copy, the same, you copy the notation, okay, from other talk you had before, okay, 2 years ago, and copy that from here. In that talk, you use circle to represent, other, the same process, okay? It's fine in that talk, but then you copy to here, then you mix up with the rectangle in the previous slides. Now you're using circle. I mean, you just confuse the audience, okay? You're just confusing the audience, okay? Don't do that, okay? Don't change the notation halfway. When using a graphic notation, make the graphic distinct and use it repeatedly, just like use the same notation throughout the talk. We should use one consistent name or label to denote one thing, okay, throughout your talk, and do not use too many variables throughout, because if you use too many variables and notations, and the audience would forget. And always define things, and your problem statement, mathematical symbol, your goal, and so on. So always define before you talk about it. When you present an experimental result, you want to report only the reproducible experiment result, such as with the condition defined, the procedure outlined, and also conclusion stated, and label your diagram and axis in graph. This is often forgot by students, because you just I see many students just show their graph, show their the pictures without labeling their diagram, without legend. This would confuse the audience. Do not overuse the animation and the graphics. Remember, form should never overwhelm content, or form follow function, just like in architecture design. Also, don't be self-centered. What is interesting to you may not hold the same interest for the audience. So always try to figure out what the audience will be interested. And you should control the talk time and with the slides. Okay, you should use no more than 15 slides per 30 minutes talk for beginner. Okay, that means do not use too many slides in a short time, because if you change the slides very frequently, that means audience may not get what you try to say. Also, you should make a lot of effort to prepare the slides. Professor Ho of Harvard University suggests that you should at least take 15 minutes to make one slide in preparation, and about 30 minutes per slide with graphics, and 1 hour talk means you have to spend almost whole day in front of a computer. I can tell you that actually I'm not that capable, so I spend a lot of more time in preparing my slides, than this. We should have a good organization of slides, and a slide consists of a title, the table of content. We should arrange the text and the graphic appropriately, as in the following examples. Okay, this is a very good example given by Professor Larry Ho of Harvard University as the historical perspective of human civilization and technology evolve. Okay, if we put a timing logarithm, okay, about 4 million BC, based on the theory of evolutions, human being began to evolve from monkey into modern human being. Professor Ho joked about this is the first genetic algorithm, because genetic algorithm is an optimization algorithm based on selection and evolution. Okay, then if we move time 3 hours of time, okay, and the human civilization began, and the human being began to use tools, learn to do farming and arithmetic. Then if we move 2 hours of time, 40 years ago, okay, because this talk was given in 1999 at the IFAC Congress in Beijing. Okay, 40 years ago means 1959. The first commercial digital computer was made by IBM, the IBM 709. The same year, the first IFAC Congress was held. Then, if we move 1 hour of time, 4 years ago, okay, Microsoft launched the first multitasking operating system, Windows 95. That was in 1995. So, you can see that using the animation and the graphics, and the audience would easily comprehend the historical perspective of human civilization and technology development. Okay, this is my slide. Okay, trying to show the audience that the importance of the energy efficiency. We know that global energy crisis is pressing. The human society's dependence on fossil energy is no longer sustainable, because we cannot use the oil and the coal and those fossil energy forever. If we look at here the energy structure of major countries, you can understand why we have so heavy smoke, because only China use almost 7% of the coal as the energy. Okay, if you look at Sweden, okay, the 90% of the energy come from the hydro generation. Denmark right now, I mean, almost 50% of energy are come from new renewable energy, such as wind and solar. It plan to use 100% of renewable energy in the year of 2050. And burning coal is not only dirty, but also inefficient. You can see here the actual utilization of coal-fired electrical energy in China. See, based on the textbook, Chinese coal mining, industry, the efficiency is about only, 30%. That means, you find 1 ton of the coal reserve, you can only dig out 0.3 ton. Then, in the thermal, generations, okay, based on the Carnot cycle, only, 40% of the energy is utilized. And also, there's 1% of the coal shipping loss and 1% of transmission distribution in power grid. Now, actually, less than 10% of the energy is actually utilized. So there is a magnifying effect in saving energy and the terminal end. So operation optimization is one of the most important approaches to reducing energy consumption and emission for electrical and energy system. What is the way out? The way out is an efficient energy system with diversified energy sources, such as we should utilize the new renewable energy sources as much as possible. We should bundling and do a coordination of energy of various sources. We should save energy on the demand side, and also we should have a demand response based on the smart grid technology. Those are the approach we can use to reduce the fossil energy consumption and make our energy system more efficient. And the demand side, in the energy consumption for the energy intensive enterprise and building consume most of the energy. So we have to make the energy intensive, the energy system for energy intensive enterprise and the building more efficient. How can we realize our goal? Actually, cyber-physical energy system, and which is part of the effort, such as the Industry 4.0 by German government and Made in China 2025 by Chinese government. Those are the effort. The cyber-physical energy system can realize really the goal. This includes the smart grid for electrical energy system, the integration of the power grid with the information network, the cyber-physical enterprise energy system, including the energy consumption sensing, measurement, demand forecasting for the manufacturing processes, and the production, conversion, storage, scheduling for multi-energy enterprise energy system. Cyber-physical energy system for buildings. Okay, we need to gather the information of the occupant, movement, environment, the equipment, and so on, in order to make a good decision to run the building energy system more efficiently. So cyber-physical energy system can comprehensively acquire energy and the environmental information, supports a bi-directional energy and the information flow, and provide a basis for optimization based on based decision and the control of integrated energy supplies and demand. So cyber-physical energy system is a key technology we can use in the future. Here is another example of good slide by Professor Larry Ho of Harvard University. We try to use these slides to tell what software optimization is to the audience. Okay, suppose we have a huge search space. If we try to find the true optimum, okay, and it is like, shooting one bullet with another one. Okay, the estimated optimal may be far away from the true optimum. What is what is the idea of soft optimization? Actually, because the difficulty of finding the true optimum, instead, we try to find a good enough set, because finding a set, is easier than finding a one true optimum. Okay. However, we still do not know where the good enough set is. Then we select a set on ourselves. Okay, we just select a set. We find the select set S. We do not know whether this is coincide with the good enough set or not. However, if we know that our select set has an intersection with a good enough set, we are pretty much okay. In this case, the intersection of good enough set and the select set happen to contain the best, contain the true optimal we're trying to find. Using animation is very useful. Here is an example of animation. We use the animation of slides present a network security defense system. Suppose here is a computer system, okay? There are two hackers trying to attack a server in this computer network, okay? And the two hackers launch a coordinated, attack on the server. And this attack, because it has a flow through the network, and it was detected or discovered by the two sensors installed in two other computers. Then this computer report their finding, okay, or sense what's going on, and report to the data center, and then also report to the console, let the operator know, and then the data center send the command and to the firewall to stop this attack, so that the attacking may be stopped halfway. Okay, using this animation, you can see very clearly that how the computer system is being under attack and how the attack is stopped.